Good afternoon, class. This is exam one review, covering chapter 1 and 2, section 1.6, 2.1 to 2.5, and section 3.1. We're going to look at the summary of what is being covered here. We want to find the general term. This is a question from the exam review. So we notice there are three parts here. The sign alternates. We have a negative sign. We have the numerators, and the denominators. We'll look at each case. When it alternates, we have to use negative 1 to the power of n or negative 1 to the power of n minus 1. Which one do you think we should use? Anybody? Would you use this one or that? Well, in this case, if you use this one when n is 1, negative 1 to the power of 1 is negative and the first term is positive, that doesn't work. But if we use this one, 1 minus 1 is 0, negative 1 to the power of 0 becomes positive 1, and this is the one we are going to use. Let's write out the numerators, 6, 10, 14, and so on. This is an arithmetic sequence because the first term is 6 and we are adding 4. So a sub 1 is 6, d is 4, and we know that the general term a sub n equals a sub of 1 plus n minus 1 times d. We replace this. And of course, this part is 4n minus 4. They combine to 4n plus 2. When we write out the denominators, we notice it's a geometric sequence. The reason why, because we are multiplying by 3 to get to 9, and the same thing here. So you divide 9 by 3, 27 by 3. So it's a geometric sequence where the first term is 3, and so is the ratio. So we use a sub n equals a sub 1, or to the power of n minus 1, and we get 3 to the power of n. We're going to put everything together. That means we're going to use this one. This is the numerator. This is the denominator. More importantly, you should always check. All you have to do, replace the n with 1. Do we get the first term? And you will. Continue. Plug in n equals 2. Do we get the second term? So you must check your work. That is extremely important. Check your work, always. We want to find the first 5 terms, which means we're going to replace the n with 1. 2 to the power of 1 is 2 minus 4 is negative 2. We replace it with 2. 2 squared, 4 minus 4 is 0. If n is 3, 2 cubed, 8 minus 4 is 4, so on and so forth. We can figure out the rest. Let's go to the next one. A sub 1 is given, a sub 2 is given, and we want to find the first 6 terms. So let's go to the next one. So we want a sub 3. If you set this one equal to 3, obviously n becomes 1. So this becomes 2. This becomes 1. And so a sub 3 is a sub 2, which is 2, plus 2 times a sub 1, which is 2 times 1 equals 4. A sub 4, according to this, would be a sub 3 plus 2a sub 2. So we're going to add this plus 2 times a sub 2, 2 times 2, 4, and 4 is 8. And we can continue with the rest of them, come up with every answer. We want to find the limits. We plug in 2 to the power of infinity is simply infinity. We plug in 2 to the power of negative infinity is 1 over 2 to the power of infinity, which is 1 over infinity, which is 0. We are using negative exponential rules. A to the power of minus n is 1 over a to the power of n. And 1 over b to the power of negative m is b to the power of m. And therefore, the answer is 5. The next one, 1 plus 1 over infinity, which is 0, makes it 1. In this case, we are dealing with a rational expression where n or x or t, it's approaching infinity. You have to divide by highest degree term in the denominator, namely n squared. As you can see, everything goes to 0 except 2 over 5. So the technique is to divide by highest degree term in the denominator. We want to express the number as a rational number in a fractional format, 0.46 bar. It's a repeating decimal, so 0.46, 4646. And we can write it in this format, or we can write it in decimal format. In which case, the first term is 46 over 100 or 0.46, and the R is 1 over 100. You may write this as a fractional form or a decimal format. It is important to notice 100 squared or 10,000 is 100 times this. Therefore, the fraction is being getting smaller by a factor of 100 or 1 over 100. So you plug into this formula because when R is between -1 and 1, we can use this. We're going to multiply the top and the bottom by 100 because this is a complex fraction. When we multiply these two, we get 46. And we multiply these two, we get 100 minus 1, which is 99. Now we are looking at the number 3.16 bar. This is the exam review question number 10. And that means 3.1666. It is only one digit that is being repeated. And so this is the part that we need to work on. So for this part, A is 6 over 100 and R is 1 over 10. You can write this as 0.06. You can write this as 0.1. I want to make sure we understand why this is the case. 10 cubed or 1000 is 10 times 100. That's why the factor of 0.1 here. And for this part, we can use A over 1 minus R, where A is 6 over 100 or 0.06. 1 minus R is 1 over 10 over 0.1. And this part It's a complex fraction. Again, we multiply by 100 over 100 because the top has the denominator 100. Needless to say, we can simplify that. We're going to keep it as such. It goes pretty faster that way. So when we multiply the top, 6 over 100 by 100, we get 6. But the bottom, that gives you 100 minus 10, which is 6 over 90. Now, we want to write this as a rational number. So to do that, we're going to add the 0.1, which is 1 over 10, and 6 over 90, which is 2 over 30. And the way we do that, this one is, if we use the common denominator 30, 3 over 30, with 2 over 30 becomes 5 over 30, which is 1/6. And that's the final answer. A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 30% of the drug present in the preceding time step remains in the body. So we are dealing with prescription, medication, and patient situations such that we have a constant amount being added at a time step 8 hours. This is extremely important, doesn't enter any of the calculations, and 30% remains. So first and foremost, let's write the given. Because part B goes with Q, we're going to use Q. So Q sub 0 is 0 because we are dealing with patient. The amount of constant is 100 milligrams, and what remains is 0.3. That means lowercase c is 100 and r is 0.3. So how much drug is left after the third tablet? If you want to make up a table, the first one we have 100, 30% of that remains. So we have 30 and we add 100 becomes 130. The next one, 30% of 130 is 39. That's what remains. We add 100, total of 139. We're going to come up with Q sub n plus 1. We're going to change the B to Q. We wrote the given, it makes life easy. Therefore, we replace the R with 0.3 and the constant with 100. We want to solve this formula. They told us Q sub 0 is 0, but generally that is the case. They should tell us otherwise. If it's not, and Q sub n, we are going to go to the solution and change the B to Q. So this solution, we change the B to Q. And now Q sub 0 is 0, R is 0.3, the same thing here, and lowercase c is 100. So replace them accordingly. We're going to simplify the expression. I can put it underneath here, and I'm going to cross it out here. And this is the same as 1000 over 7. Part D says use part C to find Q sub 3, and we've done this before. If we want to find this table in this formula, we use n equals 1, 2, 3. So for Q sub 3, simply put n equals 3. I'm going to leave it for you to check to make sure you get 139. Plug in. We want to find the limit. when n goes to infinity, because this number is between -1 and 1, this goes to 0. So we get 1000/7. And whenever we answer the question, if the units are given, we give back the same units. Always answer word problem with proper units. And what does it mean? It means if this antibiotic is taken every 8 hours times 10, it will never get beyond this much, 142.857 milligrams. We want to find the limits, and I remind you to find the limits, just plug in and observe. You get to a number, you're done. You get to 0 over any number other than 0, the answer is 0 and you're done. If you get to some number over 0, then you have to figure out if it's negative or positive infinity, because 0 is the only number that the left and right side, they have different signs. Most of the time in calculus, we end up with indeterminate form, which is 0 over 0, infinity over infinity, infinity minus infinity, and there are other forms, in which case it means more work. It means we have to use our algebraic technique to come up with the answer. For example, right here, if we were to plug in, we would get 0 over 0. And since t is approaching infinity, the technique is to divide by highest degree term in the denominator, namely t squared. We do that, we simplify. You notice everything goes to 0 except 1. So you are looking at 0 over 1, which is 0. Same thing happens here. You get 0 over 0, and because it's a rational expression where t or x is approaching infinity, we divide by highest degree term in the denominator, which is t. We simplify. And now when we replace the t with infinity, 7 over t goes to 0. The top is infinity plus 2 over 5. And infinity over any number, 5 or 5,000, makes no difference. It is still infinity. For part C, if you plug in, you get infinity minus infinity. The technique is to multiply by the conjugate and divide by it. So when you do that, it's important to know you're dealing with A minus B times A plus B, and the result is A squared minus B squared, meaning the square root comes out, becomes x squared plus 1, and then minus x squared. The denominator, nothing happens to it. These two cancel each other. And now if we replace the x with infinity, then the denominator is infinity plus infinity, which is still, of course, infinity. And the answer is any number over infinity is 0.
I have a question.
Sure.
On problem A, on the third step, on the denominator, where did that plus 1 come from in the very beginning?
We're talking about this step?
The third step.
This one?
Yes.
Okay, we are dividing by t. So this is 5 over t, this is 7 over t squared. T squared over t squared is 1. 2t over t squared is 2 over t minus 1 over it. Does that work? Perfect.
Yeah, I get it now.
Excellent.
Thank you.
My pleasure. All right, we are going to move on. Again, in every step, we simplify. All right, we want to come up with the limits. In this case, I want to explain e to the power of minus t, which is 1 over e to the power of t, and it becomes 1 over e to the power of infinity, which is 1 over infinity, which is 0. This is the part you want to be careful of. Therefore, the final answer is 12 over 4 equals 3. Part B, it is not a rational expression because the top and the bottom must be polynomials to be a rational expression. However, following the methodology, we divide by highest value in the denominator, which is e to the power of t, because it is approaching infinity. We do that, we simplify each expression. This becomes 1, this becomes -3. 5 over e to the power of t, 4 over e to the power of t, both of them go to 0. We end up with 1 over -3, which is -1/3. In part C, if you plug in, you get infinity minus infinity. In this case, the technique is factoring. So we're going to factor out the x. Now, if we plug in, we get infinity times infinity minus 1, which is still infinity. It's important to know infinity times 2 divided by 2 times 10 to the power of 2, all of them are infinity. We are given the graph and we are asked to come up with the limit of the function as x approaches 2 from the left, from the right, and as x approaches 2. So the one-sided limit says the limit only exists if the limit from the left and the limit from the right are identical. So the limit of f of x as x approaches a equals L if both sides result in the same thing. So from the left of number 2, we are in this branch, and that gives us number 3. From the right of number 2, we are in this branch, and it gives us a different answer, which is 1. Because the two are different, the limit of g of x as x approaches 2, dne, does not exist. We're going to look at the same situation, this time number 5. So when we approach 5 from the left, this side, this branch, we are moving towards this hole that has the y coordinate 2. If we come from the right side of number 5, we are in this branch, we are going towards the same hole, having the same answer. Because the two are identical, the limit of g of x as x approaches 5 is 2. So if we look at number 5, we have a dot. If we look at number 2, we don't. That means in this case, g of 2 is not given to us. It's undefined. We don't know what it is. But in this case, g of 5 is equal to 1.4. Definition of a continuity says if the limit of f of x as x approaches a equals f of a, the function is continuous at 5. So at 5, the limit does exist, but the functional value is different, and therefore it's discontinuous. Can g of x be continuous at g of x equals 5? First of all, it is not the way it's given, because g of 5 is 1.4, and the limit is 2. The two are not identical. However, since the limit exists, if we redefine this to be 2, we can fix it. This discontinuity can be fixed, and it's called removable discontinuity. But this one, we have a jump. We can't fix it. In this case, the limit of r of x as x approaches 2, we look at the two along the x-axis from the left side and from the right side, both sides going down to negative infinity. When x approaches 5, both sides of number 5 blows up to positive infinity. But when it comes to negative 3, it depends on the left side. So from the left of negative 3, the answer is negative infinity. But from the right of negative 3 is positive infinity. And by definition, now we have VA or vertical asymptotes at x equals negative 3, x equals 2, x equals 5. Those are the equations, and those are the lines. We use dashed line to represent vertical asymptotes. We want to find the limit. Remember, we plug in, and if you plug in, this one becomes 0 over 0. Therefore, the technique is the conjugate, you multiply by the conjugate of the numerator and you divide by it. So it becomes 0 over 0, because if you plug in and it gives you an answer, you're done. Since it's 0 over 0, we use one of those techniques. Now this is A minus B times A plus B. The answer is A squared minus B squared, which means this comes out as x plus 3 minus this becomes 4. Positive 3 and negative 4, they combine to x minus 1, and we can cross out x minus 1 and x minus 1. And now if we plug in 1 here, square root of 4 is 2, 2 and 2 is 4. The answer is 1/4. I want to look at 26 and 27 together, and I want you to notice in both cases the numerator is 6, the denominator is 0. Now, whether we come from the left or right, the numerator in this case is like 6.1, in this case like 5.9, makes no difference. But the denominator makes a difference, because are we coming from the right or left? We have a different sign. So for example, for this one, let's use 6 from the right as an example. 6.1 minus 6 gives you positive 0.1, and 6 over 0 from the right, that gives you a positive infinity. However, in this case, 6 from the left, something like 5.9 minus 6, and it's negative 0.1. For the sign, you can even say 5 minus 6. We are looking for the sign. So it's 6 over 0 from the left. Positive over negative is negative infinity. When we plug in 4 here, we get 16. Because 4 is from the right, we get a number a little bit larger than 16. So although the answer is 0, but it is important to write 0 from the right, because ln of 0 is not defined, since the domain is 0 to infinity and 0 is not included. And if you recall the graph, looking like this, it's going towards negative infinity. And of course, what that means, as you can see from the graph, VA has the equation x equals 0. All right. For number 32, if we plug in, we do get 0 over 0. But even before you plug in, perhaps because it's a rational expression, you want to factor out. And from the top, you can take out x. The bottom becomes x plus 5 times x minus 5. As I mentioned it before, since x is approaching negative 5, we must have a factor of x plus 5. If it's approaching negative 10, we should have a factor of x plus 10. These two cancel each other. And now if I plug in negative 5, the top becomes negative 5, the bottom becomes negative 10. The answer is positive 1/2. For number 33, also we get 0 over 0. It is a complex fraction, and the technique is to multiply by LCD, which is 3x over 3x. And when we multiply 3x by 1/3, we get x. When we multiply it by 1 over x, we get 3. So the numerator becomes x minus 3. The denominator, we don't touch it. These two cancel each other. We get 1 over 3x. And of course, if you plug in now, you get 1 over 9. For number 34, simply plug in. So you get 0 plus 16. So the square root of 16 is 4. In other words, it just works out. Plug in and observe. For number 35, if we plug in, we get 0 and we are done. So plug in, it works out. For number 36, if you plug in, you get 0 over 0. You multiply and divide by the conjugate. This is a minus b again, a plus b, and the answer is a squared, which means 49 plus h comes out, minus b squared, that means minus 49, and the denominator, you write it as a product. These two cancel each other. You have the h in the denominator, the h in the numerator, they cancel each other and we get 1. If we plug in 0, square root of 49 becomes 7. 7 and 7 is 14. So 1 over 14 is the final answer. If we plug in for number 37, we get 0 over 0, but the best course of action is to factor out. Because you get 0 over 0, and because x is approaching negative 4, we should have a factor of x plus 4. So you already know that you have a factor of x plus 4. And since this is 3, you need 3 here. Since this is 2, you need 2. So you can easily figure out what happens by trial and error. This is negative 4. So you need, if this is 4, you need negative 1. This is 12. If you need 4 here, you need 3 here. So it becomes a very easy case of factoring, believe it or not. So x plus 3, x plus 4, and x plus 4 cancel each other. And if you plug in negative 4, the numerator is 3 times negative 4, negative 12 minus 1 is negative 13. The bottom is 2 times negative 4, negative 8, and 3 is negative 5. And the final answer is 13 over 5. The last topic we looked at was this concept. Again, this simply gives you the slope of a line, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Rise over run. Everybody is familiar with that. Now, this one, if you call this a, and you call this x, that's the way it looks like. If you look at this one, if you call this a and then the distance of h, this is a plus h, you come up with this formula. These formulas are referred to as DQ, difference quotient, but it's just a good old slope. Now, the blue lines are called the secant lines, and the red line is what we are interested, which is the tangent line. As we get closer and closer to P, we get to the tangent line. Therefore, we define the instantaneous rate of change as follows. The slope of a tangent line is the limit of m of PQ, the slope of this line PQ, which is a secant line, as Q approaches P. If we go with this one, as X approaches A, if we go with this one, as H becomes 0, as H approaches 0. It's the same thing. And then we have the equation of a tangent line, as I've mentioned it before. It is the point slope, and you want to stick with the point slope. You don't have to even memorize that. But as far as the point slope goes, this was the formula. Y minus y sub 1 equals m times x minus x sub 1. So let's find the equation of a tangent line, and we have to use the definition for the sake of the section. And we can use one of those. In fact, for practice, again, I'm going to use both. So if we use this one, we replace the f of x with x squared, and by the way, a, of course, is the x coordinate of the pair. So we want that. And now f of x is x squared, and f of 1 you can plug in, or it's been already given to us. And again, sometimes they may give you just the x coordinate, not the pair. You plug in and you find the pair. The top becomes x plus 1, x minus 1. You can drop the common factor of x minus 1. And now if you plug in, you get 2. We go with the point slope formula, y minus y1 equals m times x minus x of 1, which means y minus 1 equals m2 times x minus x of 1, which is x minus 1. And it becomes y equals 2x minus 1. And you can check it if you plug in 1. That works out because this pair belongs to the graph of the original function as well as the tangent. We are done with this, but I want to look at the second method for practice. So if we go this route and we replace the a with the x coordinate, which is 1. So f of 1 plus h, we put it into the original function y, or f of x. F of 1, you can plug it in or just use the y coordinate here. Either way is fine. And squaring this gives you 1 plus 2 times the first times the last 2h plus h squared. 1 and negative 1 cancel each other. We factor the h out. It drops. And now if you plug in 0, you get 2. And as you can see, this is the same as here. Again, you don't have to do both ways. This is for practice. And there you have it. The distance in feet of an object from a starting point is given by s of t, sometimes they may call it f of t, equals 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? I want to stick with that for now because this is elementary algebra. And basically, you divide the total distance by the total time, and that gives you the rate or speed or velocity. So we plug in 4 and we plug in 2. So S of 4, replace the t with 4, S of 2, replace it with 2, and S of 4 is 52, S of 2 is 38, divided by 2 is 7, and just to quickly show you, if I were to calculate this to get this one, I'm going to say 2 times 4 squared minus 4 times 4 plus 40, and that is 52 because 4 squared is 16 times 2, 32. Minus 20 plus 40. You can do the same thing with number 2. The second one is the instantaneous velocity, which is now calculus. Again, we have 2 points in time, it's average. When we have 1 point in time, it's instantaneous, even if they don't mention that. Which means we use the same concept as before, taking the derivative at a, where a in this case happened to be 4. So we want S of 4 plus h minus S of 4 over h, and we want to take a limit of that as h goes to 0. So let's plug in 4 plus h here, which means 2 times 4 plus h squared minus 5 times 4 plus h plus 4d, and then minus S of 4. Again, you can plug in 4 as I did here, or just use the fact that we've come up already with 52. So I plugged it in, and I'm going to use the fact that it's 52 in a moment. First and foremost, this part is 4 squared is 16, plus 2 times 4 times h is 8h, plus h squared, and we are going to multiply by 2, which gives us 32, plus 16h, plus 2h squared. So we multiply by 2. Minus 20, minus 5h, plus 40, minus, this one we already know the answer is 52. Let's put it in. Now let's combine the numbers. (32) minus 20 plus 40 minus 52. They add up to 0. 16h minus 5h. They add up to 11h. So the numerator is 2h squared plus 11h only. We are going to factor out the h. And now when we plug in, we get 11 feet per second.